All right, so we're going to talk about complex numbers. Let's start with this example, the square root of negative 16. In algebra, when dealing with real numbers, we say that this operation is not possible, that you cannot take the square root of a negative number. Specifically, we say there is no real solution to this, or that this is not a real number. The reason is when you're taking the square root, you're trying to answer the following question, is what squared gives you negative 16? The issue is that you can't square any number and get negative 16. For instance, if you tried negative 4, negative 4 is not, negative 4 squared is not negative 16. Negative 4 squared is actually a positive 16 because the negatives cancel each other out. In fact, it doesn't matter what negative number you're talking about over here, but you can't square any real number and get a negative, because again, the idea is whenever you multiply two negative numbers by themselves, the negatives will cancel each other out. You'll end up with a positive. And obviously, when you multiply two positive numbers by themselves, you'll end up with a positive. So the question becomes, what if we need to? And there is a purpose in physics and engineering. For when we multiply, we want to get a negative number out, like negative 16. So how do we make that happen? So we invent a new number, and the number is I. And what I is a number that when you square it, you get negative 1. So this allows us now the ability to square a number and get negatives. And that number again is I. So I squared being negative 1 is really the definition of what I is. I is the imaginary number. But another way of thinking about that is I equals the square root of negative 1. So we have I equals the square root of negative 1, or I squared equals negative 1. The same statement, just written in two different ways. And these are the definition of the imaginary number.